This video is about basic Java programming. I'm going to show things using Greenfoot, a small gaming framework, as an example. And it's going to be about conditions and if statements. So it's going to be all about how you can make the program behave in different ways. And it's the very basic of all programming, really, that we can have conditions and if statements. And I'm going to end off also talking about how we can use it in loops as well, because conditions are also used in loops, but I will focus on if statements here. So first off, you probably already know about boolean operators or operators in Java in general. So we have different operators in Java. I tried to put some of them here. This is the equals operator. This checks, for example, if we have a variable a and we do like this and b, it will check if a and b are the same thing. If the same, then it will be evaluated to true. So if they are both the same, we'll get the value true from this. This is why we call this boolean operator, because it returns a boolean saying if it's true or false. If a and b is not the same, then it will return false. So we can do the opposite, a not equals b. So the exclamation mark here denotes not. So if it says not equals, we know that a should not be equal to b. If not the same, then we get true. And of course, if a and b really are equal, then we get false. So these will work on anything in Java, like objects and also numbers and stuff like that. But on numbers, we can also have the other operators that we see here. So for example, we cannot check if, for example, if I write John is less than Johnny, this is not valid. So we cannot do anything like that, because these operators here, they only work on numbers. They don't work on something that like objects that we cannot compare like that. But we can do things like we can say like 3 is less than 2, which is obviously false in this case, because 3 is bigger than 2. Or we could do 3 is less than 3, which is also false because that's not true. So we can actually say that what is true is 3 is equal to 3. That is true. So the reason why we use the double equal sign here is because we've been using the other equal sign, like just one equal sign, for assigning a value to a variable. And Java simply cannot understand if we mix the two. So let me show you. So we can write something like int I equals 5, and this will assign I to 5. So now I will be equal to 5. So if we wrote something like I is equal to 6, then we wouldn't get a Boolean value. We wouldn't be using it as a comparison here, like here. We wouldn't be using a Boolean comparison because it's an assignment operator. And it cannot know if we're doing this or we're doing this. So it cannot kind of guess what we're trying to do here. So they've chosen to say that if we want to compare something, we simply have to have 2 for comparison. And this is true for many programming languages, that it's done like that. It simply cannot just guess what you want to do. So it's very important that we remember to have two of these. Java is pretty strict on using assignment in certain places where you should be using the comparison operator. So you probably won't get into too much problems, but in other programming languages like in C++ or yeah, probably other languages as well, you'll get into a lot of trouble because you can actually use the assignment in places where you shouldn't. So be careful with that. Another thing you could do is, for example, now I've shown these, maybe I should also add that there is the not operator in itself. So, for example, I could say something like 3 equals 3, which we already know from up here will evaluate to true. But what we can actually do is we can put a parenthesis around this and then put the not operator here, and that will actually negate the value of that to false. And we can do that with anything. We can kind of flip it from true to false or false to true. So we can use the not operator like that, but usually what we would do in a case like this is we would say 3 is not equal to 3. So that would also be true. So these are the basic Boolean operators that we have here. In this specific case here, we need something like, we need two different variables. We need one on each side. So we cannot write something like 3. That wouldn't make sense. We need also to have a number or something on the other side. Otherwise we can't compare it. Same is true for this operator, the not equals. We need something on both sides. What's special about the not operator is that it works with only one, because it only needs to flip one value. So whatever is with this operator, we simply just need to have a single one. There we don't need like we cannot put one on both sides, like 3 not 3 wouldn't make any sense, right? Also not 3 wouldn't make sense because 3 is not a Boolean value. It's not true or false. We cannot flip the value of 3. 3 is not inherently true or inherently false in Java, so we can't say not 3. That wouldn't make sense. So it kind of expects some kind of Boolean value here, or we could say that it expects either true or it expects a false value here behind this. So it's kind of special because it only has a single one. I already showed for the other ones. We already know from math this is less than. I didn't show larger than. It's just the opposite, right? If I flip this, this will be true. So if then 3 is bigger than 2, that's right. So it's pretty straightforward. When we use the less than or equal to, we just include the one. So for example, if I go here less than equal to 3, then it would be true because it would take both the ones that are smaller than and the one that's equal to, and because 3 is equal to 3, this would evaluate to true. So you should just remember that the operators are sensitive in the sense that you have to end with the equal sign. So you cannot say equal to like this, or you cannot say like this. Sorry, like this. So this is not valid. So the operators, the first one should not look like this, not valid, and this one is also not valid, but it should be the less than or greater than first. So we have to put like this, or we have to put like this. This is valid, if I could spell it. So these are kind of the basics that we need to know to get started with this, that we have these kinds of operators that we can work on. And there are also some other operators that I'm going to talk about later. like under some of these, but I think it will be too much theory now if we don't get started. So kind of to get started with everything and not have like just a simple text output, which is pretty boring, I pre-made this small game to kind of show what I'm talking about with these conditions and how we can use them. So a bit of introduction to the game. It's not really a game, it's more like a simulation. So we have this ant here, and the ant is I can move it around right now because the game is not running, but I have this ant, and the ant is hungry. So if I click act one time, I can see that it has a hunger of 1000. And this is just some random number. It doesn't really matter too much, but when it's hungry, it will go and search for the food, and this is kind of like a super ant. It always knows where the food is, so it's not going to look too much. And when it's not very hungry, it will just move around randomly. So I'll show you what it looks like. So now it goes for the food. Now it's not very hungry, so it kind of just moves around. When it gets to around, can't remember how much right now, I'll show later, but at some number here, I think it's 100, it starts moving towards the food. Other than that, it just randomly moves around. When it gets to 500 hunger, it gets really hungry, and it starts moving a lot faster. I don't know if the numbers are, yeah, we can't see that, but it moves pretty slowly until it reaches around 500 and moves faster. If it goes to 1000, it would move like really fast. So this is what the small ant does. And you can imagine that there's some logic behind this. So first thing, I need to check how hungry it is. So I need to use these conditions. I need to say, is it more hungry than this, or is it less hungry than this, or what should you do then? Should you go in one direction or the other? These are all based on these conditions here. So what I want to do, I want to show the code that I made for this. The counter part is not very interesting. This is just the one hanging up here. The fries, they don't really do anything. They're just spawned in random places, so they are not very interesting. The interesting part is the ant. So the world as well is not interesting. The only thing it does is it spawns the ant, it spawns this fries, and it spawns this counter up here. So let's look into the ant code. So if we look to the Java code that's inside of the ant, we will immediately see some conditions. Don't worry too much about the code. If it's too much for you, then no problem. I'll just go through it very slowly, explaining what it does. So first off, I have this instance variable here called hunger. This is a number denoting how hungry the ant really is. So I just set it to 1000. I could set it to 1,000,000. I could set it to 1. Doesn't really matter. I just need some value for this. Then what I do is I say each time that time goes by, because this act in Greenfoot, each time that I can't remember, maybe I think it's 25 times per second, it runs this method. So the hunger will go up by 1, 25 times per second or something. So this way it will quite fast become more hungry. So the first thing I do is I try to check here if it touches the fries. And no, really what I'm checking here, I'm saying get the one object that is intersecting, that is fries. So if it finds the fries, this value will be set equal to the fries object in this game. So what I'm doing here, I'm using the not equals operator here, which we saw over here, because I'm checking to see if the fries, the value of this variable, is not equal to null. Meaning, because I know if it's not touching the fries, this will be equal to null. So here I needed to use not equal because I wanted to check if it's not null. So if I do intersect with the fries, I want to eat the fries. So I made another method for that down here. So I say eat food and then fries. And what that method does is it basically just counts up the hunger by 500. Oh, sorry, down. It counts down. So each time I eat some fries, it counts hunger down 500. So this is, yeah, pretty simple. So now comes the more like, so yeah, this is an example of an if sentence. We can say that if I'm touching the fries, these two lines of code is basically saying if I'm touching the fries, then eat them. So anything going after the if sentence here is what it's going to do. One important thing to notice here is that it's only going to do one line here. So although I write one more line and I do something here, let's say I wanted to move the and 6, then you can see in Greenfoot it denotes that with this color that this if sentence only works for this line and not this line. So this line is actually going to be done no matter what. There's no condition on this one, so I should put it here. But Java doesn't really care about indentation or anything like that. So the way that Java understands scope is with these curly brackets here. So if I wanted to have it, I could also put a curly bracket here, and then I could end the curly bracket here. So now the scope of this if sentence is going to be everything in between these two curly brackets. So if I wanted it also to move, I could write move, sorry, and then put some value here, and then it would move 5. Whenever it has eaten the fries, it would move. So that's pretty nice. But I don't want to do that, so I'll keep it like this. So this is just a normal conditional statement. So here I use it to check if it needs to eat the food. So this is just the if sentence. But sometimes we want more than that. We can see for the next part of the program, I'm also checking for some other numbers. So here I'm using the greater than operator for checking things, but I'm also using else, and I'm using else if, and I'm using all of these different constructions here for conditional execution of the code. So let me explain what that means. So just like the other sentence, I'm checking if there is any fries. Here I'm checking if hunger is bigger than 800. So I kind of define hungry for this and if its hunger is greater than 800. So it means if it has run this act method more than 800 times, it's going to be a bit hungry. So if it's more than 800, it will turn towards the food, a method I have down here, which just finds the food on the screen and turns the ant towards it. Then I move 5, which is a lot faster than what it normally does. I can't remember. I think, yeah, it normally moves only 2, so it moves really, really fast towards that food if it's more hungry than 800. So that means that because I set hunger to 1000, it will start moving really fast when I start the game. You can see it's really fast, right? So let's go back. So it moves really fast when it's really hungry. So what I wanted to check is that if the hunger is between 800 and 500, I want it still to move faster than normally, but not too fast, really. So I still turn towards the food, of course. I need to find the food. And then I move 3, which is a bit faster than normal because it's hungry, but it's not crazy hungry yet. So this is how I move 3. So when we do if and then we do else if, it will only go to the second line if the first line is not true. So if we look at 1000 here, this will be true, and if the first one is true here, then it will skip everything that says else. So if it's more than 800, it skips everything and just keeps going. So this is pretty smart. We can save some CPU power because we don't need to check all of this stuff here. We can simply just check the first one and then do that. So the next situation we could be in, because everything above 800, it will go in here and skip the rest. If it, let's say we would start with something like 400 instead. And let me just, so now I'll manually start the game. So you see now it still keeps going up the hunger here. So now it is moving 3 pixels per move. It's probably hard to see, but it is, because now it is in between 800 and 500. The way that works is I'm checking if hunger is bigger than 800. This will then evaluate to either true or false. In this case, 434 is not bigger than 800, so it will go to the first else of this. Because I also have an if here, it will now check this condition. Is hunger bigger than 500? Let's go and check. No, it's not bigger than 500. So we'll go back. So this will evaluate to false. So it will now, because this is false, it will go to the next one. Again, we have a condition, so it checks the condition. Is it bigger than 200? Now it actually said, yeah, it's bigger than 200. So because it was smaller than 800, smaller than 500, and it's bigger than 200, it now goes in here, turns towards the food and moves 1. So when I said it moved 3, I was actually wrong. I said that wrong because I didn't remember the 500. So it's actually between 200 and 500 and not between 500 and 800. So we should actually see when it gets closer to the 500, it should start moving faster. So I can show you that by just making small change. So if we go 490 in the beginning, and I'll just reset everything. So now it starts moving only 1, and as soon as we get above 500, because it was, now it's 500, now it's 501. And if we go and look, now it's going in here because now it's larger than 500. So now it should start going 3. You see it moves faster now because now it's above 500. So that is really interesting. And I think I can even cheat here by using the, maybe I can do, no, it only has the act. I can't remember if I can set the values here. No, I can't do that. I can't cheat. Okay. But we can cheat by going and so if I start getting close to 800, we can also see that working. So 790, going back, we can see it moves 3 and then it should start. Now it's 800, 801. So now it should really start moving faster because now it's 5 pixels that it moves each time that it goes here. And we can also see when it actually eats it, the hunger goes down by 500 and it's getting close. So we saw 800 something, now it's 300 something. So it looks about right. We can even see it kind of speeds up at 500. Not always. Doesn't hit 500 very often, so maybe my numbers are a bit off. I should have maybe said it differently, but yeah, you probably get the idea. So the if-else simply works this way, that if the first condition is not met, it will go to the next one. So in this case, this is not met, it goes here. If this is not met, it goes here. And then all comes down to the last one called else. And in the last one here, we can see that there is no if here. So this will simply, it would be the same if I wrote like this, if true. Because in all other cases, it will simply do this. So what you can see here is I created a construction of if-else here, that if the hunger is bigger than 800, it moves fast. If it's smaller than that, it moves slower and slower. And otherwise, no matter what, it just moves randomly. So you can say that this construction here, it will have to go into one of these. And if it doesn't go into the three first ones, it has to go into the else part of the construction. So it will kind of always do something here. There's no way that hunger can have any other value than something that is in here. Because the hunger is an integer, and integers needs to have a value. It cannot be null or anything like that. So we have a construction that it has to go in here somehow. So these are basically our basic if sentences and what we can use them for. And if you're interested, I can also show some of the other code here. There are some Greenfoot mumbo jumbo here where I really don't delete the fries. I just remove them from the world and then add them back into the world at another location, 20 pixels, random location, at least 20 pixels from the edges of the screen. Yeah, and then this is where I also remove the 500 from hunger. And if the hunger goes below 0, I just set it to 0 because it cannot be more than full. That's kind of the way. So here again, I use a condition. I'm saying if hunger is less than 0, just set it to 0. So if I'm in a situation where the hunger is, let's say, 200, and I subtract 500, it will go negative to minus 300. So I simply just say, if the hunger is less than 0, just set it to 0. This way it will never turn up on screen as 0. And basically it wouldn't really matter, but for any user of a game, it would look not very nice to have a negative hunger. It seems weird that you can kind of overeat and then not eat for a long time, I think. So this is why I did it like that. So basically what I used in my program, I used the not equal structure for comparing to objects. I just used it with null to see if there wasn't any object. Then I showed you briefly how we can negate a boolean value from true to false or false to true by using the not operator. I also showed you how we could use these greater than or less than, and I could have also used the greater than equals, because in this case it doesn't really matter too much if it's 500 or 501, but I can show you I can put the equals here and it wouldn't do much of a difference to the code. It does work the same way. You should be careful, as I said. You cannot do it the other way, then you'll get a weird error and stuff. So remember, always put the greater than or less than before the equal sign. I don't even think I used the equals one in any of the if sentences. You can also see sometimes I don't use any of these operators because I get the value from somewhere else. Let me show you the bottom here. So here I have a method that is inside of this game library called intersects. It simply checks if it's touching the fries. And so I'm checking if the ant is touching the fries, and if it is, this will return true or false. So here I just use it with a condition coming from another method. So we can set any method, to return a true or false with this, writing boolean here. So this is what they did in Greenfoot. The authors of Greenfoot, they would put that so that I can use it in my if sentence. So anything goes here as long as it evaluates back to either true or false, we can put it inside of the if sentence. So conditions can be true or false. It's as simple as that. So now I only have kind of two things that I want to talk about in this video that are somewhat related and interesting, I think. But if you understand most of this, it's really great, because these are the basics of if-else constructions and conditions. So I just wanted briefly to talk about the switch statement. So switch is another way of doing forks in the execution of the program. So if I'm going up here, so in this case, I'm saying if, else, if, else, if, else. This would actually be a case where we could use a switch statement. So let me try to convert this into a switch statement instead, just to show you. It's not any different. You can do everything that you want to do with if-else construction. Switch is just another way of writing if-else in your code, and it's just preferred in some cases. It's a bit easier to read, and maybe in this case it would be. So let's try to do that. So first off, the code word is a switch, and what we want to do is inside here we want to write what is the variable that we want to check. And in this case, if we look here, it's hunger. Like this is the one that changes the flow. So I'm going to write hunger here like this. And then we need to put scope around this to say this is where the switch statement works. And then we write case, and then we need to write some kind of statement about what we want the value to check for. So what we're looking at here is something like 800, 500, and 200. But the switch case is a bit different, because here case actually means the same as equals equals. So if I do something like I write 800 here, then whatever needs to happen when hunger is equals to 800, I have to do it here. So in this case, it's probably not the best, but let me just show you here. So what you would do is you would put these in here, saying these are the things that I want to do for this code. And the last command would then be break. And you would write then the next one, case. Then you would write something like 500 colon, and then again you would do whatever was here, and you would write something like, for the last one, kind of the same thing. So I'll just copy paste it with the 200 and move 1. So now I kind of copied the structure. You can almost see 800, 500, 200. The problem with case statements is that it needs to be exactly equal to 800. So when I go above 800, it will no longer move 5 or below 800. So it's not the same as up here. So in this case, the switch case statement is not really a very good structure for this. So the last thing we need to, we also need to have a break here and a break here. We have to use break on the cases, and then the last one, just like the else statement here, we use a default like this, and then we put the last one here. So I hope it's not too confusing that they're not exactly doing the same thing, because we cannot do exactly the same thing with a switch case, because the case part is the same as the equals equals operator. So it needs to be exactly 800, exactly 500, exactly 200. So it's not really like the best comparison here. But the structure is the same. So the way that this works is it switches on this variable here. If this variable is 800, it does this. And break means the same as the else, so break means it will go out of the switch statement and continue the rest of the code. If it goes into the 500 one, it will do these two and then break and go out of the code. And the last one here, 200, break out of the code. And just like the else statement, it kind of catches the rest. So in all other cases, it simply moves randomly. So this wouldn't work too well, but anyway, it would somewhat work, because immediately when it goes to 800, 500, or 200, it's going to start moving towards the food. Let me just show you that it does work. But it works a bit differently, because it's not going to move any faster, it's going to move only 2. So let's just put it like here. So we can see immediately when it goes to one of the numbers, like when it reaches 200, it starts moving towards, see? When it's exactly 200, it will move towards the food. Or it's exactly 500 or 800. So it works a bit differently, but yeah. So this was just to show you another way of doing else if statements. And I think switch is really not used that much. It's used in very special cases. So if you find it a bit harder to use, just wait with using it. You can do everything with an if else that you can do with the switch statement. No problem. So if I should compare them directly, we can make the switch statement look exactly like the if one. It's a bit slow here. So if I want them to be exactly the same, it would be simply replacing here and using the comparison like this. Now these two pieces of code does exactly the same thing. And if you could see the compiled code behind the scenes, they would probably compile to exactly the same thing and react exactly the same way. So there's no right or wrong in using these two. I think readability is what you want to go for, if you want to go for one or the other. There's a couple of things I want to say as well. There are another set of operators that is interesting. One of them is called and there's one called or. And then I want to talk about loops, and I'm doing a video on loops as well, so it's only going to be kind of like a very short way bridge to talk about how loops also use conditions. So two operators I didn't talk about are a bit special. These are boolean operators. They work on booleans only, just like equal equals and not equals will work with two booleans. So what they do is the AND operator checks if both are true. So for AND, if we have true and true, this will evaluate to true, because both of them are true. If we have false and true, this will evaluate to false, because one of them are false. And when we're saying and, we want both one and the other to be true. So if we have true and false, we also get false. And the last case we can have, because we can have 4 different ones when it's only Boolean, right? So if they are both false, then they will also be false. So only in the case where we're comparing two of the same, two true booleans, we will get true. This is the AND operator. And this is used a lot in programming, where we want multiple conditions to be true in order for this to work. There's also the OR operator, and it looks like 2 pipes. On my keyboard in Windows, I'm using Alt-GR and the key left of the backspace. I don't know if it's just my keyboard that's like that, but something like that. And on Mac, it's some Mac key and then the I on your keyboard. I can't remember which one, but something like that. And you have to have two of them, and same with the AND operator. There is also another operator which is only one and for now just don't use that. It has another usage on bit operations and stuff like that. And the same for the pipes here. Always use two of them. It's kind of like with the equals and equals equals. For now, just use the two. I won't go into details with that, but use the double one. So for the OR operator, it's different. So if we have true or true, this evaluates to true. Because with the OR operator, either one or the other needs to be true. So if I say, let's try to copy the construction from up here, makes it a bit more fun. And then I simply just change this around. So in this case, one of them is true, so it's true. In this case, one of them is true, so it's true. And in this case, one of them is true, so it's also true. So the only case where it's false with the AND operator is when we have the special case that both of these are false. Let's just set it up like this. Looks a bit better. Right? So we can see that they are not the same. And this can be used in different cases. So let me see if I have something in my code here where I could show this. So in this case, for example, I have an if sentence, and inside of that if sentence, I also have an if sentence. So sometimes this can be meaningful, but in this case, it's not very meaningful. So let me just find something else. So let's just take this back to the original. So if hunger is greater than 800 or greater than 500 or greater than 200. So let's say that I want one last ditch towards food before I kind of check. Yeah, I don't know. Let's try to do something where we check if the fries are bad or something instead. So let's go down here where we're trying to eat the food. Let me explain this really briefly. So this if sentence checks if it intersects with the fries. But what if I want to check if the fries are bad? Let's say that I have a method inside of fries that tells me if they are bad or not. I can make that real quick. I'll show you. So right now they don't do anything. So I'll make a public method in here. Public boolean is bad. And then I'll just return false because they are never bad. These are always good fries. Okay, so we'll go back. So now we can actually check that. So if we wanted to check if the fries were bad, what we could do without knowing about these two operators is we could simply just say that if fries, is bad, like this, and I need to move it in like this. Okay, so now I check if it intersects with the fries and the fries is bad or are bad. That means that I cannot eat them. So what this actually does, it actually eats them. So I don't want to do that. So if they are bad, I don't want to eat them. So I'm going to say if they are not bad. So if the fries is bad, not, I'm simply just skipping this. And because I always return false, they are always good, then this doesn't change the code too much. It's more to show you the idea that we can have nested if sentences like this. But what we could do instead of this is we don't need to have a nested if sentence like that. We could do the same to say if it intersects with the fries and it's not bad. Let's go put it here. Now this does the exact same thing as before, but just in one single if sentence. Maybe it's easier to read, maybe it's not. So it says, if it intersects with the fries and it's not bad, then do this. And other cases you can imagine you just want one of them to be true. For example, if I have multiple kinds of food, we could check, is it fries or is it sugar? Then you're going to eat it. If it's anything else, you're not going to eat it. It might be rocks or whatever, some other objects. The counter, it shouldn't eat the counter, for example. So stuff like that. So then we would just want to check those two. Is it sugar or is it fries? Then we eat it. Otherwise, we don't touch it, right? So that's pretty nice. So this is just the last two operators, and this is the last part of this video I wanted to show. So again, remember everything with these operators, that we can remember that you have to use two equal signs. That's one is very important. Remember that this means not, and remember that these are used for numbers. And then, as I said, if you don't understand the switch right now, wait with that. It's not used that much, and you can do everything you want with this if-else construction. No problems. You don't even need these parts. These are just else and else if. These are just simply for making it a bit easier to work with. So just start by understanding if and the condition, then you're really very far ahead of everything. So I hope it's not been too confusing mixing actors and fries and counters and ands into this, but I just wanted to try to make it just a bit more interesting this way. That's it for this video, and I think my next video will be about these loops instead that I haven't gone through in this video. So as I said, I think this video is fairly long now, so I won't go into more detail, but loops are also using these conditions, and if you want to know more about how and why, you can watch the video that I'm making about conditions as well. Bye.